So, like I've hinted at several times before, for your internal, all the questions are going to be word problems, so we've got to be able to work our way through them. So what we've got now is a few problems with GS, the geometric sequences, and after that we'll start applying arithmetic and geometric sequences all mixed up together and trying to decide which one's which from there. But here we're again looking at trying to understand when we're looking for just using this formula and when we're going to be using the sum formula. So this is for a single value. So this is like on a day, how much after an hour, and this is your total, or your sum, or words like all together. And for geometric sequences, we do have to keep in mind that the ratios are commonly written as percentages, like they've said here. And we've got to remind ourselves if we're increasing, again, that's going to be 1 plus the percentage over 100. And if it's a decreasing percentage, you're going to go 1 plus, sorry, not 1 plus, 1 minus the percentage over 100. So turning that into a decimal. So as the situation is here, I'm increasing by 25%. So R is going to be equal to 1 plus 25 over 100. Or if you are good at converting percentages directly to decimal in your head, that's 1.025. You can just write it out without doing the calculation, just kind of doing it in your head. So in a question like this, they've given us lots of information. On the first day she runs 4 kilometers. Okay, so we've got A is equal to 4. We figured out R because it's increasing by 25%, so R is going to be 1.25. And then here, what's the distance she will run on the 8th day? So because that's kind of a singular thing, on the 8th day, what is the distance? Here we're looking for T sub 8. So again, to diagram that out, if you're more familiar with it that way, we have first day is 4. We're looking at here, on day 8, how far is she going to run? So plugging it in, making sure you use brackets around the 8 minus 1, or just avoid the brackets by putting in 7, doing the 8 minus 1 in your head, and you'll be okay. And watch out for units especially as well. If we go to the second part of the question, how far in total here. So here we see that word total, we're looking for the sum. And watch for tricky things, like what's the total run in 2 weeks? Well, everything that we know is about days so far, so how many days in 2 weeks? 14. So n is equal to 14, r is 1.25, and a is 4. Plugging it in, watch your brackets on the bottom, you'll get your answer. So as you go reading through these problems, just watch out for the keywords that help us decide whether or not we've got to look with the t formula for just a value of a particular term or for the sum, and also get used to how the geometric sequence problems actually sound. So usually if you're increasing by a percentage each time, that's going to be a geometric sequence, versus an arithmetic sequence is like increase by the same amount each day. So Sam is hammering a tomato stake into his vegetable garden. With the first strike, the hammer goes 20 centimeters. Alright, so we've got A is 20. Each strike after that makes the stake go further 80% of the previous distance. So here, 80% of the previous distance. Well, it's kind of trickily worded because they don't have an increase or a decrease. But that 80% is just going straight to the R value. So here we're not increasing by 80% or decreasing by 80%, it just is 80%. And here, if it is a value without increasing or decrease, you have to remember to just convert that to a percentage, to a decimal. So 80% divided by 100 is going to get you 0.80, and that will be your R value. So slightly different situation here. Increasing by a percent or decreasing by a percent. When they use that word, increases by or decreases by. If it's just percent of problem, like we saw, then you're just going to use that percentage that you've got. So R will just be percent divided by 100, versus the difference when you're increasing or decreasing. So here, 80% of, R is going to be 0.8, plug it in, and just watch out again for your brackets, or do 5 minus 1 in your head and get 4. And the second part, how far into the ground will a stake have been driven by the 5th strike? Okay, so think about this. We've got, on the first blow, he puts it in 20 centimeters into the ground. On the second one, well, it's going to be 20 times 0.8. So we're going to have 16, because we're timesing by 0.8 each time. And the third, we're going to get 12.8, and you keep going, and out to the fifth strike. So what's happening here is kind of like driving the stake into the ground. The first time he hits it, you know, it's at the surface of the ground, he hits it, and it gets a little bit further in, and then he hits it, and it gets a little bit further in, and a little bit further in. What we're seeing is that the first time it goes in 20 centimeters, the second time it goes a further 16 centimeters, the third time it's a further 12.8 centimeters. So here we're actually looking for how far total, in a way, the sum of all of them. So you're going to use the sum to the fifth term is what we're looking for. So using n is equal to 5, you've got your r and your a, use your sum formula, watch your brackets, and you should be okay. So it is probably the hardest part about this internal is just interpreting these problems correctly and reading them carefully. So take your time and get used to looking for those hints that tell you whether you're using the value or the sum, and also getting used to trying to identify why it's a geometric or why it might be an arithmetic sequence into the future.